noise. Yeah.
Okay, cool. Thanks. Okay, so 6, 7, 6, 8, 6, 9 are sections that cover word problems. A lot of the word problems that are in my sections I took directly out of my intermediate algebra material. So you may have seen some of these before. In sections 6, 7, all the word problems are money-ish word problems, and there's two formulas that we have to know, and the first one's sitting right here, and let me just talk about this formula just in case you weren't exposed to it in intermediate algebra, or if you forgot what the formula can be used for. So this is a formula that was written for problems 1 through 4. It's called the compound interest formula. This formula can be used to figure out how much your investment in a savings account might grow to over a given period of time. Like this question says I have $1,000. It's earning 3% interest compounded monthly. How much will there be in 10 years? This is a classic formula that can be used to answer just that kind of question. In order to do the word problems, you have to know what the variables in the formula stand for, and that's what I need to start off doing. So in this formula, the A is going to stand for the amount of money in the future, so it's some future amount. And the P stands for the starting amount, the beginning amount. I'm not sure I could spell beginning properly, so I probably should have written starting. The R in the formula, which is the next letter, so A is the future amount, P is the beginning amount, 1's just the number 1. R is the interest rate, but it has to be in decimal form. In most of the word problems in this section, the interest rate is given as a percent, and we'll need to change the percent into a decimal by moving the decimal over 2 places to the left. There's 2 n's in the formula, and the n is the number of times interest is paid per year. And generally, if you look in the problem, you're going to see the word compounded, and the word after compounded is supposed to help you figure out what end is. So if you look to a problem, any of the problems in this section, there's probably going to be somewhere in the problem there's going to be a word compounded. The word directly after compounded, it might say like monthly, or it might say quarterly. The word after compounded might be annually. I think that's another word I don't think I could spell. Maybe there's only one N. Sorry about that. So anyways, after monthly, if it said compounded monthly in a word problem, the N would be 12. And then if it said compounded quarterly, and I was doing the word problem, a quarter is 3 months long, like January, February, March is the first quarter, April, May, June's the second quarter, July, August, September is the third quarter, October, November, December is the fourth quarter. If the word quarterly came after the word compounded and I was using this formula, I'd make n equal to 4, and that can't be spelled right. Sorry about that. Kind of talking with an English professor these days, and so it'd be kind of embarrassing that I can't actually spell that, and there's no spell checking with this. Anyways, if it said interest is paid annually, the n would be 1, because you're getting interest once per year. And then the last variable in the formula is the t, and the t is going to refer to the number of years that the investment is being invested for. So with that in mind, most of the word problems in this section are just going to involve taking numbers from the problem, throwing them into the formula, and then solving for the missing letter. So in each of the word problems, I have to know the numbers that are given, what they stand for, and what I'm trying to solve for. So if I get into the section here, The first word problem says I have an initial deposit of $1,000. It earns 3% interest compounded monthly. How much will be in the account after 10 years? So there's key figures in this problem. This $1,000 is going to be relevant to when I solve the problem. The 3% interest is going to be important when I go to solve the problem. Always the word after compounded is going to be important when I attempt to solve the problem. And then the last number I see is the 10 years. So I'm supposed to understand what each one of those things that I circled or underlined or boxed means relative to this formula. And it's going to be the case that I'm going to be given values for every single one of the letters except one. My goal is going to be to solve for the missing letter. A is the nicest missing letter because if A is the missing letter, I can directly get my answer with using my calculator without having to do any algebra. If A is not the missing letter, if I'm given A, then all of a sudden I'm going to have to do some algebra before I can get to my answer. So as I read through the problem, the word initial deposit of $1,000 means that the $1,000 is the beginning amount. So that tells me that the P in the formula is 1,000. The next thing I see is 3%. That's clearly the interest rate. There isn't a decimal written after the 3%, but there's an implied decimal after the 3. And to change a percent into a decimal, I drag the decimal over 2 to the left. Here I'm going to have to add a 0. And I'm going to use 0.03 for the value of R in the formula. The N has to do with the number of times interest is paid each year. And again, it's always, I get clued into the N when I see the word compounded. The word after compounded tells me what the N should be. Because there's 12 months in the year, the N is going to be 12. And the last thing that I have underlined, the 10 years, is a time frame, so I'm going to write T equal to 10. So I'm going to take those four values and plug them into the formula. And this is the kind of problem because I don't have a value for A. I won't have to do any algebra. I'll be able to get the entire answer via my calculator. So I'm going to take these numbers best I can, plug them into the formula, and I can get my answer without doing any algebra, just completely calculator. When you use your calculator, this right here has to be in a parentheses. If you don't put this 12 times 10 in a parentheses, you won't get the right answer. If you multiply 12 times 10 in your head and write 120, you will get the right answer. But I'm going to enter this on my calculator just how it's written, other than I'm going to put the 12 times 10 in a parentheses. And hopefully I can make it so you can see the calculator. So I'm going to go 1,000 parentheses 1 plus 0.03 divided by 12, up arrow, parentheses 12 times 10. And when I hit enter, this is going to give me a dollar amount. It's probably going to give me more than 2 decimals, but because I'm dealing with money, it's implied that I need to round to 2 decimals. So I'm going to say in 10 years, that $1,000 is going to grow to $1,349.35. So the answer to problem 2, I'm just going to put a dollar sign and write $1,349 and rounding that 35.3 cents to 35 cents. And that would be as well as I could do. Again, I'm not sure how that actually shows up okay today. That's all there is to do for number 2. Similarly, that's probably all there's going to be for number 4, because 1 through 4 in the same grouping of problems, I think they'll have the same technique to get them solved. And the technique would be read the problem, get the variables, plug the variables in the formula, and similarly, 1, 2, 3, and 4 are all going to have me solve for A, so that I'm going to be able to, once I get the formula set up, go straight to my calculator to get the answer. So as I read through problem 4, just like I did problem 2, I'll look for numbers and keywords. The $12,000 is a key number. The 1% interest is going to be key. The word quarterly after compounded is going to be key. And then the 10 years. I wasn't that creative with my years in this problem. It's essentially the same problem as problem 2, just written with different numbers. I'm going to take each of these things that I have lined, circled, or rectangled and attach a letter to them. The 12,000, because it's the initial deposit, it stands for the P. The 1%, because it stands for the interest rate, it's an R. And I'm going to change that interest rate to a decimal, make it 0.01. The N is the number that gets implied by the word after compounded, because there's 4 quarters in the year. January, February, March is the first quarter. April, May, June is the second quarter. July, August, September is the third quarter. October, November, December is the fourth quarter. I'm going to put 4 because there's 4 quarters in a year, just like there's 4 quarters in a dollar. And then again, T is going to stand for 10, the number of years. I'm going to take those values, plug them into the formula, and I'll get A equals to 12,000 times 1 plus 0.01 over 4 to the n times t times the 4 to the 4 times 10 power. Again, when I go to use my calculator, I'm going to put this 4 times 10 in a parentheses. If I don't put the 4 times 10 in a parentheses, it won't think the 10 is part of the exponent. So I'm just going to go straight to my calculator again, go 12,000 parentheses 1 plus 0.01 divided by 4, up arrow, parentheses, 4 times 10, close out my parentheses, hit enter, and you can't really read that, but it says I get $13,269 and 39.6 cents. I'm going to round that 39 cents up to 40 cents because the 6 after the 9 makes me round up. So after 10 years, my $12,000, I'm going to get $1,000 worth of interest and come up with $13,260.40. Putting a dollar sign probably looks nice because it's money. So those are the friendliest problems in the section. The next problems are probably going to be not quite as friendly, but not horrible. Though they're still calculator-only problems, but they involve a new formula. In each of the last few problems, problems 2 and 4 that I did, the word after compounded was a finite word. I had compounded monthly, there's 12 months in a year. I had compounded quarterly, there's 4 quarters in the year. In the problems between 5 and 8, after the word compounded, you see the word continuously, and that means interest is paid more than every second of every day, more than every tenth of every second of every day. It's paid constantly, and you never stop earning interest. And these sorts of problems, the problems between 5 and 8, if I was to use the other formula, that it would be appropriate to use infinity for the n. And because I don't know how to do algebra with infinity, because this isn't a calculus class, in calculus you learn how to do algebra with infinity, we pull out this formula. So when the word after compounded is continuously, the formula that we use for problems 1 through 4 is not the appropriate formula. This is the continuous interest formula. And the letters mean the same things. The A is still the ending amount or the future amount. The P is still the starting amount. The R is still the interest rate as a decimal. And the T is still the time in years. And you'll notice there isn't an N. The formula for the E kind of gives me the N equal to infinity. E is like this. E is 1 plus 1 over infinity to the infinity power. And somehow the E kind of gobbles up the N, the infinity for the N. So I don't have to worry about an N because the E kind of takes care of the N. My calculator has an E button, so these problems are also not going to be so horrible to do. So as I start problem 6, I'll read the question the same way. I start looking for keywords or numbers, and there's 4 of them in this problem. The $10,000 initial investment, the interest rate at 5.25%. The word after compounded is continuously, which means I need to use the formula with the E for money as opposed to the formula with the N, and then the 8 is the number of years. So in this formula, I'd like to have values for A, P, R, and T. I know I have a value for E. E is about 2.718, so I don't need ever a value for E. It's already pre-programmed into my calculator. The numbers that I have in this problem, the P is the starting amount, which is $10,000. R is the interest rate as a decimal, which is 0.0525. T is the number of years, which is 8. And I'm going to solve for the amount in the future, so I'm solving for A. So I'm going to throw those numbers into the formula and get A equals 10,000 times E to the 0.0525 times 8. And again, I'm going to need to put that exponent in a parentheses. And to get the E, I'm going to have to hit my second and my ln key on my calculator. So again, this is purely a calculator problem. I'm going to go 10,000 and then second and ln for the E. And then after that, it's going to be 0.0525 times 8. So if I enter 10,000 and then E to the 0.0525 times 8, I get $15,219, and that's 61.5 cents. I'm going to round to 62 cents. And my answer to this problem is, after 8 years, my $10,000, because 5% is a reasonably decent interest rate, especially in today's world, I'm going to come up with $15,219 and rounded to 2 decimals because it's money, 62 cents. 8 should be similar in that it's in the grouping from 5 to 8. I'll probably need to solve for A again. I'm going to be given values for P, R, and T. I'll throw them into the formula and use my calculator. Once we get beyond 8, the problems are going to have algebra before I could use my calculator. So again, I read through the problem. I see a dollar amount that stands for the beginning amount of money. I see the interest rate in a percent form. I see the word compounded continuously. The continuously after the compounded means I use the formula for money that has the E in it. And then I see a time of 22 years. The formula's hinted at me on the top of this page. The P is the starting amount, and that's this $120,000. The R is the interest rate as a decimal, which will be 0.0225. The T is going to be 22 years. Take those values and plug them into the formula. I'm going to go A equals, and then I'll write 120,000 times E to the 0.0225 times 22. And again, I'm going to have to, when I use my calculator, put the exponent in a parentheses. Now it's just a calculator problem. I go 120,000 second ln 0.0225 times 22. And when I hit enter, assuming you could actually see that, it's just, this glare is just insanely horrible. So I typed 120,000 second and ln, and then that stuff. And then when I hit enter on this, I get $19,685. And I'm going to round that to 98 cents because the 8 after the 7 tells me to round up. So my answer is going to be $19,685.98. Now the problems are going to have some algebra. The rest of the problems, a lot of the rest of the problems I think we're going to be solving for T, which makes the problems a little bit harder. At least this next problem we're solving for T. 10 and 12 are certainly problems where we're solving for T. So as I read through the problem, I start to look for key numbers and key words. And always, dollar amounts are important. Interest rates are important. The word after the compounded is important. And in this problem, there's a sneaky word that's important, and it's the word double. We haven't got to that yet because that word hasn't been in any of our problems, but that's a key word in this problem. So as I read through the question, immediately when I see the word compounded continuously related to money, I know I'm using the formula A equals PE to the RT. So that takes care of the continuously part of this. The next thing I see is the initial investment is $1,000. So I know that P is $1,000. I also know that the interest rate is 6%, so that the R is 0.06. I don't see, like I saw in the first few problems, a number of years that was given. And that's because I'm solving for the number of years. The question, the first two words say how long, and how long means I'm solving for time. And that the T is going to be the letter that I don't have a value for. And I'm supposed to actually have a value for A in this problem. And that's where the word double comes in. I want to double my $1,000. Double means multiplying it by 2. And this is really asking how long will it take my $1,000 to grow to $2,000. Because I'm doubling $1,000. So that keyword that I circled in red is the word that's going to help me find the A. So this problem's going to be harder. And notice I said round to 1 decimal place. I'm solving for the number of years it takes for this to happen. And it's not as necessary to round to 2 decimal places. When you're dealing with money, it doesn't make sense to go more than 2 decimal places. But in this case, I'm just dealing with time. Could round to the nearest year, but I just said round to the nearest tenth. So I'm going to take these numbers and plug them in the formula. And it's going to require algebra. So I'm going to go 2,000 for A, that's the future amount, equals 1,000 times e to the 0.06t. A few steps to solve this. First step, I'm going to divide both sides by 1,000. This we're going to do a ton. This little column of algebra, between the next 3 sections, it's going to come up, 20 times. So eventually you'll get good at this if you're not good at solving this kind of problem right now. So when I divide both sides by 1,000, I get 2 equals e to the 0.06t. Now I'm going to take the natural log of both sides. I'm going to leave the left-hand side with its natural log. But on the right-hand side, I'm going to make the exponent a coefficient because I'm allowed to do that. So let me do this in a parentheses, not that it's really necessary. But I made the exponent the power into a product. I used the power to product rule or the exponent to multiply rule. And I know that natural log of e equal to 1. So this side here is really 0.06t times 1, so it's just 0.06t. So I can rewrite this as the natural log of 2 equals 0.06t. I can divide both sides by 0.06. The right side I can do the division without a calculator. The right side, the 0.06 cancel, and it actually takes me to my answer for t. And on the left side, I'm going to use my calculator, and I'm going to round to 1 decimal. So I'm going to go to natural log of 2 divided by 0.06. So I go ln 2 divided by 0.06. And when I do ln of 2 divided by 0.06, I get 11.55. The instructions say round to 1 decimal place, so I'm going to round to 11.6. And because this is time, and the time is in years, because the interest rate's a yearly interest rate, I'm going to write 11.6 years for my answer. I think 12 is a similar problem in that I'm going to have to solve for t. Anytime I see the words how long in one of these money problems, I'm solving for t, and there's algebra to do before I use my calculator. If I see how much for a question, then I'm usually just solving for A. Or what will the value be? So immediately in 12, I see the word how long. How long tells me I'm solving for t. As I read through the problem, I see a few numbers. I see $10,000, $15,000, 4%, and then compounded continuously. Again, the word compounded continuously tells me I'm using the formula A equals PE to the RT. The $2 amounts, the $10,000 is the initial amount, so that's going to be the P. The $15,000 is the amount in the future. That's what I want it to grow to, so that's going to be a future amount. It's an A. The R is going to be 0.04, and that's all I need. The T is what I'm solving for. So in this formula, you only need 3 variables, and you'll solve for the 4th. So I'm going to put the numbers into the formula and get 15,000 equals 10,000 times e to the 0.04t. Solve this just like I did problem 10. I'm going to start off dividing both sides by 10,000. I believe that gives me 1.5 on the left side. I'm take that as a decimal. We'll make sure that's not wrong. I'm going to go 15,000 divided by 10,000, and it does give me 1.5. So I get 1.5 equals e to the 0.04t. Now I'm going to take the natural log of both sides. I'm going to leave the left side alone for a bit, leave it at the natural log of 1.5. On the right side, I'm going to make the exponent 0.04t a coefficient. I don't really need this parentheses, but it's okay to have it. So I took this 0.04 and wrote it in front of the logarithm. Because the ln of e is equal to 1, I can cross that out, and I get the ln of 1.5 equals 0.04t. I'm going to divide each side by 0.04. On the right side, the 0.04s are going to cancel. I'm going to have my t isolated. Left side, I use my calculator, and I'm rounding to 1 decimal place. So I'm going to go the ln of 1.5, parentheses close, divided by 0.04. So again, that's ln of 1.5 divided by 0.04. I see 10.13. I'm going to round it to 10.1 because it says 10.13, and my instructions say round to 1 decimal place. I'm going to use 10.1. So my answer for this, it's going to be time. So I'm going to tag on the word years next to my number. That 10.1 doesn't represent money. It represents the length of time to go from $10,000 to $15,000. So I'm going to write 10.1 answer. 10.1 years would be perfect. I'm not sure if the next problems want me to solve for t or not. I don't think they do. Yeah. 14 and 16 and 18 all use the formula. They deal with money, but it's not really investing money in a bank. 14, I have a house, and I want to find out what it's going to be worth in the future. As I read through the problem, it's in the money section. I look for the word compounded. The word after compounded tells me the formula to use. If it said compounded continuously, I'd use a formula with the E. Because the word after compounded says annually, I know to solve this problem, I need the formula 1. If I could actually write this right. I need the formula A equals P times 1 plus R over N to the NT power. Again, this is P times 1 plus R over N. My R's and my N's look strikingly similar. That's the formula that I need. A equals. Now we go through the problem. So I'm assuming that house is worth $150,000 today because I want to know what it's going to cost in 10 years. So in this particular problem, that dollar amount is it's a value today, so it stands for a beginning amount. The next thing I see is 10, and it says 10 years, so that must be the time. The next number I see is 2%. That's a growth rate. That's more or less an interest rate. So I'm going to make my R 0.02. And then the word after compounded tells me what N should be. And annually is the word that means 1. If it said monthly, it would have been 12. If it said quarterly, it would have been 4. But annually means that you get interest once per year. I'm just going to take those amounts and plug them into the formula. And this is a nice problem. I'm not going to have to use my calculator. I'm not going to have to do logarithms in there. I can go straight to my calculator. So I get 150,000 plus times 1 plus 0.02 over 1 to the 1 times 10 power. Because I'm solving for A, I can go straight to my calculator. I'm going to put that exponent in a parentheses. And because I'm solving for a dollar amount, I'm going to round to 2 decimal places. So I'm going to go 150,000 times 1 plus 0.02 divided by 1, up arrow, parentheses, 1 times 10. This is being lazy and not simplifying all the ones in the formula that I might have been able to simplify, but it's not necessary, although I missed a 0 here on the 15,000. So I needed to make it 150,000. I only had 15,000. Now when I hit enter, it says the house will be worth $182,849.16. So that's the value of the house in 10 years. That's assuming it goes up 2% per year. Of course, we all found out that home values can actually go down. When at one point I would have told you that could never happen in Phoenix, but it certainly did. So anyways, that would be an appropriate answer for problem 14. The 16 and 18, I think, are similar problems in that they want to know what something's going to be worth in a certain amount in the future, or what something's going to cost in the future, and then we'll do them exactly the same way. We'll use the same formula. And again, as I read all these money problems, immediately I want to know what formula I'm going to use. If I'm not told the formula ahead of time, I search for the word compounded. If I don't see the word continuously, I know I'm using the formula that doesn't have the E. In this problem 14, as well as the problem 16, the formula I'm going to use is that problem because I don't see the word continuously. As I read through, the first number I see is a $300,000 house today. That's the present cost of the house. The T, the 20 years, stands for time, so it's going to be a T. Here, my home value is going up by 2.5% as opposed to 2%. I'm going to make that into a decimal, and then I need an N, and if I'm only getting growth once, computing the growth once per year, the N is 1. Take those values and plug them into the formula. I'll get A equals to 300,000 times 1 plus 0.025 over 1 to the 1 times 20 power. Again, if I'm not doing that multiplication, I need to put that in the parentheses. And I go straight to my answer. So I'm going to go 300,000 times 1 plus 0.025 divided by 1, up arrow parentheses, 1 times 20. Definitely didn't have to type as much as I typed. You could have voided out some of those ones and still get the same answer. So this $300,000 house in the year 2032, or whatever, 20 year, maybe 2036 if this is 2016, will be worth, so the answer is going to be worth $491,000, $491,584.93. Of course, that's just an estimate because there's no way to know for sure if houses are going to go up on an average of 2.5% for the next 20 years. They can, they can go up by 1%, they can go up by 6%, they can go down. But if you get an average return of 2.5%, so some years more, some years less, but if you average 2.5%, your house should be close to $500,000 in 20 years if you currently have a $300,000 house. Last problem in this section deals with tuition, but it's not any different than finding the value of a house. So I said a local community college has tuitions at $60 per credit hour. I think we're more than that now. I want to say that I took classes at GCC, oh gosh, when I was in high school. That would make it, maybe I took classes in 1981 at GCC, and gosh, maybe tuition was $5 a credit hour, or $7 a credit hour. I forget exactly what it was. I know that in 1982 at NAU, it was $325 per semester to be a full-time student, and that for your tuition, your books, your meal ticket if you lived on campus, and your dorm, it was under $1,500 for a semester, probably a lot closer to $1,000 a semester. Under $3,000 for a whole school year for what that's worth. But that makes no difference now because I can't go back in that time. So anyways, again, I look for the word compounded in all these money problems. Once I don't see the word continuously, I know that I need to use the formula A equals P times 1 plus R over N to the NT power. and I start hunting out dollar amounts. The $60 is the current cost of the tuition. It's the present or beginning cost. The 3% is the growth rate. I'm going to make that into an R with a decimal. Because it says compounded annually, the N is going to stand for 1, and the number of years is going to be 10. I'm going to take those values, go the future tuition equals the current tuition $60 times 1 plus 0.03 over 1 to the 1 times 10 power. Again, I'm going to toss some parentheses around there when I use my calculator. So I'm going to go 60 parentheses 1 plus 0.03 divided by 1 up arrow parentheses 1 times 10 and hit enter, round to 2 decimals. It says in 10 years it's going to be $80.63 per credit hour. So answer $ since it's money around to 2 decimals, $80.63 per hour. Fortunately, you might be lucky if that's all it goes up, but tuition's been going up by way more than 3%. They've been jumping tuition statewide by 10, 15, 20% per year. I think tuition has maybe doubled in the last 4 years at the state universities, and not as much at the community colleges, but it still went up quite a bit. So that's this entire section. So hopefully, as a word problem section goes, it wasn't the most frightening word problem section. For me, it's a friendly section because it's money, and money problems make more sense to me than non-money problems. So hopefully that felt good. And if not, come visit me. I can make up more problems for you if you need more practice problems. And if you're just kind of completely baffled, I can sit down and help you one-on-one to get through whatever's making you not understand it.